Hello, my name is Andrew Rush, and this is my Physics 2211 lab that deals with constant velocity. In this video, we will go through the introduction, the fundamental principles used in this lab, the procedure, and then our data being the observed motion, our computational model using GlowScript, and after we will compare our observed versus predicted motion to see where some possible errors were, and after that we're going to interpret the data. So our introduction, the purpose of this lab is to compare the change in velocity of an observed object traveling at a constant velocity to a predicted computational model, like I said, the GlowScript. The observed motion is an expo marker, and GlowScript code is the predicted model, like I said before. And then also we want to understand how Newton's laws works on real objects. Some fundamental principles include the Newton's first law, which states that an object in motion stays in motion unless acted upon by an external force. This means that an object with a constant velocity will move in a straight line at a constant speed. In addition, Newton's second law states that force equals an object's mass times its acceleration. Something to interpret with that is a heavier object requires more force in order for it to accelerate or decelerate, and a lighter object will require less. So the way that this relates to the lab is that an object that has constant velocity has a net force of 0 and has no acceleration. In addition to these principles, we will also use the velocity update formula and the position update formula. So our procedure to do this is that we will record a constant motion of an object along a flat surface with a meter stick along the path to calibrate it. We'll then import the video to the tracker app to analyze the video in order to extract the object's positions and times. We then use the momentum principle and other fundamental principles to manipulate the GlowScript starter code to correctly portray the motion. We then compare the two graphs given by the observed and predicted motion. So right here is our computational model. This is the code that we used, the tracker app, to analyze this data. As you see, we get the net force and we apply the momentum principle, and then we advance the clock to show, the object's velocity over this specific amount of time. So the specific amount of time being our 2.402 seconds and our initial position of 0.104, we use that data to calculate the change in velocity down there being the 0.324 meters per second in the positive x direction. With that, we were able to interpret it and relate it to our predicted versus observed. As you can see, our predicted is a straight linear graph, but the observed motion deviated from that slightly. So some sources of error of this can be the surrounding forces being friction and air resistance. There's also some issues maybe with the tracker framing in the center of mass. In the video, the marker may have slightly deviated from a straight line. Overall, this lab was very successful, and our computational model and observed motion matched very well, only if we ignore the outside forces, but those are some that we can't. So, thank you so much.